So my research area is natural language processing and software localization. Before joining Kathmandu University, I worked for about 5 years at Madan Puraskar Pustakala, and there we did a lot of work in Nepali language localization. So today I'll be talking about NLP applications for empowering the society. So how many of you have heard about NLP? Could you raise your hands? Okay, that's good. Quite a few, right? Okay. NLP. So let me just. So today, basically, I'm talking about what is NLP. NLP stands for Natural Language Processing, right? Natural language processing, and then further moving on, I'll be talking about how natural language processing can be used as a tool to bridge the digital divide. Then I'll be talking about components of NLP. So what are the components that comprises of NLP, and then why is NLP difficult? Then finally some natural language processing applications so as to connect to the top. I mean how NLP tools could be used as a means of empowering the society. Right? So that's the outline of my talk today. And as we move ahead, you can basically ask me questions in between as well. But I think to make the talk smooth, so that we have enough time for all the speakers as well. So let's keep the questions to the end. Is there anything to navigate or the slides? Okay, that's good. Thank you. Okay, so those of you who are familiar about NLP is the NLP word cloud. So there are a lot of terminologies and words that you can see which frequently occur in NLP literature or NLP text. All right. So yeah. So next slide. So what is NLP? Natural language processing, right? So this is natural language processing is a sub-discipline of artificial intelligence and computer science. All right, this is a sub-discipline of artificial intelligence and computer science, and NLP is the short form for natural language processing, which you already know by now. All right, and this involves two things: natural language understanding and natural language generation. Natural language generation and natural language understanding. Right? So natural language understanding is all about making the machines understand human language. Because I mean there is a communication involved between humans and machines, right? In everyday life. So natural language understanding is about making the machine understand human language. And natural language generation on the other side is about making the machines generate text or speech, right, as close as the human language. So that's the basic terminologies involved with natural language processing. That's natural language understanding and natural language generation. Both of these are complex tasks. However, it's considered that natural language understanding, as making the machines understand human language, is a little bit more complex task. Okay, go to the next slide, please. So basically, to understand what is NLP, there is a small illustration. So we have the user, and then we have two users, for example, speaking different languages. One could be English, the other could be Nepali, for example, and then we have this machine, right? And this is a typical illustration which involves machine translation system, which most of you must have heard about, right? Machine translation system basically translates text in one source language. It could be English, and then it translates into target language. It could be Nepali. So here, as you can see, I have already shed light about NLU and NLG, right? So NLU is about making machines understand human language. So if you provide some input, it could be text or it could be speech, right? So the machine has to have that capability to understand that particular input. That's natural language understanding. Natural language generation, on the other hand, is about processing the human language which the machine gets as input, and then generating generating the output in such a form that which is very close to the human language. All right? So this is basically small skills about which explains what NLP is and what are the components of NLP. Next slide. Again, we are very familiar about chatbots, right? This is a very fancy application these days. Everybody is interested in developing chatbots in one form or the other. So basically, chatbots. We have these different chat applications or chatbots, and then there is this natural language NLP layer or natural language processing which happens because in order to make the machine understand our language, human language, it has to be processed in the form that a machine would understand, right? There has to be a natural language processing layer, right? And then there would be knowledge base. Right? There would be knowledge base. Knowledge base basically includes, let's say, dictionaries, for example, right? Or it could be some rules, right? So that dictionaries and rules, and rules meaning that's not just simple rules, but it could be inferential rules as well. Right? For example, if it rains, if it is a rainy day, then we carry an umbrella, right? Before getting out of home, we carry an umbrella. So that's the inference that works in our human minds. Similarly, there should be some inferential engine and inferential rules as well, and then lexicon together with these rules comprises the knowledge base. Right? And then data storage, that is the interaction history and analytics. So past communications and all those stuffs also would be there. And based on this, the chatbots works. Next slide. Okay, now let's talk about the digital divide. So what is really the digital divide? There is a joke, in fact, let me share that, right? So it was I think back 10 or 12 years ago, the digital divide was a big hype. The terminology was a big hype, and everybody was talking about it, everybody was pronouncing the digital divide, but not really understanding what the digital divide is, right? And there was a meetup or some conference, press conference or something like here, right? Maybe 100 to 150 people. Then one guy just raised his hand and then stood up and asked, "Everybody is talking about the digital device. When is this device coming in the market?" Right? So people were talking about it. It was the digital divide, not the digital device, but people misinterpreted it as a device, not a divide, right? So let me just talk about that. So digital divide. Digital divide is about the access, having or not having access to information technology, right, or content, right? It could be because of both hardware and software, right? I don't have access to the hardware, I don't have a laptop, I don't have a mobile phone, or I don't have a tablet and all those things. And because of that, I don't have access to information technology. That's from the hardware perspective. That's the digital divide. I don't have access to the content or technology, right? And then again, but then, as you can see, hardware is getting cheaper and cheaper every day, right? So that means the affordability to buy this hardware has actually increased in the common people as well. Right? These days, typically, you don't need a computer or a laptop or all these things to have a Facebook account, right? For example. So, however, having a hardware or a device does not necessarily mean that you have access to the technology or you have access to the content. This is because, there is this software aspect also coming into play. The technology might not be in your language, right? The technology might not be in your language, or the technology might not be understandable, it might not be accessible, it might not have features which are very comfortable for you to make it more usable. So scientists all over the globe are working really hard to address this digital divide via NLP. And we'll see in today's talk how these different technologies are actually helping to bridge the digital divide. Next slide. Okay, talking about the components of NLP, there are a whole lot of components, right? We have phonology, for example, which deals with the study of systems of sounds in a particular language. The way we speak, right? As I say, each language has its own set of phonemes and alphabets and all those things, right? That's phonology. Then we have, moving on to the, basically we can divide NLP into two parts, speech and text. Speech and text. So speech is basically dealt with phonology, all right? And then moving on to the text part, we have morphology, right? Morphology, which is basically the study of word forms or different lexical forms, all right? So morphology deals with the word or lexical forms and involves breaking down the word into its roots and affixes. Affixes could be prefix, infix, or suffix, right? There could be some agglutinative languages, where there could also be circumfixes, right? However, in Nepali, for example, we have just a prefix and a suffix. All right. Prefix and suffix meaning, let's say we have this, some mathiko, right? Or gharmathiko, for example, we have one word. In that case, we have two suffixes, mathi and ko, whereas we have one particular stem word. All right. So that way, our morphology deals with the breaking of the words into its roots and affixes. Then moving on to syntax, of course. Now we move on to the sentence level, and this syntax deals with the grammar and grammatical structure of a language. So how do we, for example, in let's say programming language, if you don't write code complying to the syntax of the language, then it will give some error. A compile or the interpreter will throw some error. Right? Similarly, how do we affirm, how do we ascertain that a particular text, particular sentence is compliant with the grammar of the particular language? So that's basically dealt with the syntax. Then it's moving on. We have semantics, which deals with the meaning of the text. Right? A grammatically correct sentence does not necessarily mean that it is meaningful. It could be meaningless as well. All right? So that's about semantics, and then the discourse. Moving on to higher levels. So basically, from beginning from morphology, we are gradually moving into higher levels. From the word or lexical level till to the discourse level. That's a discourse level. Basically, it deals with the meaningful connections between texts. Right? Not if you just accumulate, if you just collect text, gather text, this does not mean that they would have meanings or they make some senses, right? So, in order to have these meaningful texts, there has to be a interconnection between the texts. Whatever you are talking in the second paragraph should have some relation to the first paragraph, or whatever you were talking in the first sentence should have some connection with the second sentence. So this is basically done with the discourse. Second. So again, moving on to shedding light on the components of NLP. This is basically diagram which actually has a connection or a pipeline. Let's say starting from speech, and then moving on to all to the different components of NLP. For example, morphology, syntax, semantics, and then again moving back to speech. For example, we have lately this Google Assistant, right? Or even Siri or Cortana, right? So there is a speech-to-speech interaction. So this diagram, in fact, actually explains the different modules or different steps that any such system would actually undergo before coming with a final output. Next slide. Okay, so what NLP is difficult? NLP is difficult because language itself is, difficult. We don't even we humans have difficulty sometimes understanding not others' language but our own language, right? Because language is dynamic, right? And language, it's not straightforward. Sometimes we don't write or we don't speak what we mean. Right? We need to actually have deeper contextual knowledge or word knowledge to understand what is being intended, right? So one of the biggest challenges of NLP is ambiguity. Ambiguity meaning to say that there could be different senses. The ambiguity could be in the word level, that's in the lexical level, or in the higher levels, right? So, for example, in the word level, there is this word called bank, B-A-N-K. right? This could be a financial institution, building, or a riverside, right? So we need to have enough context to actually find out which bank we are actually referring to, right? And then in the phrase level, for example, we have this phrase or a clause, let's say, make up a story. Make up a story. If we just take individual words, then that might not give the same meaning as to what a complete make up a story would actually mean. And then in the semantic, in the sentence level, for example, there is this sentence: Iraqi head 6 arms. Iraqi head 6 arms, right? This is basically a headline of news, right? So if you just take individual words, it could mean something else. It could mean head. It could be part of a body, right? Arms, again, part of the body, but that's not what it means, right? And other interesting part of a language, as I said, the language is dynamic, language is complex, and it gets evolved time and again, right? So, for example, there have been several words which have actually been coined as verbs, which have been established as verbs. For example, Google, the word Google, right? I think even the founders of Google might not have imagined that someday it would be a verb. These days, I mean, if somebody says, let's Google it, then we understand that you are necessarily saying you are searching for something, right? And then I will email you, right? Email is already a verb now. Just email me. You say, just email me. Email is already a verb now, right? Similarly, once I have heard this verb as well, football. Basically, it's a noun. But I've heard the statement or it's a sentence, let's football. Okay. So word knowledge is required to understand the context apart from the linguistic knowledge. For example, if you encounter this sentence, unfortunately we don't have the Dharwara Tower in Kathmandu anymore, then anybody not having the prior context of the earthquake in 2015 would not necessarily understand the actual cause of why Dharwara is no more, right? Is it taken away by somebody, stolen by somebody, or it's toppled down? Right? So there are a lot of things that actually make NLP different. And challenging and interesting as well. Right? Next slide. These are some of the NLP applications that's been listed in the figure. Group 1, Group 2, and Group 3. Basically, these have been grouped in a way. I mean, the Group 1 forms the most basic applications, basic NLP applications. For example, we have this tokenization, which is basically we're tokenizing a sentence. That's a one word per line and all those things. So in Group 1, that's the most basic application, moving on to more complex applications. All of these are different applications that could be useful in a society, and that could be that's required for the latest technology to actually get to realize. Next slide. Okay, now I'm going to give a brief overview about the different useful applications of NLP that could be useful to the society and to any of us in general. So, spell checker, right? Most of us must be already using some form of spell checkers, and let's say most of the editor softwares like Word documents and all these things. Right? So, spell checker does two things. It detects any misspelled words, right, in the text, and then makes suggestions for corrections on the misspelled word. That's the role or use of a spell checker. Then we have the stemmer and morphological analyzer. Stemmer and morphological analyzer. In this case, this application takes a word and breaks down to its stem or root form and its affixes, prefix, infix, and suffix forms. The actual use of the stemmer and morphological analyzer comes in information retrieval, right? For example, search engines. So if we have a stemmer in place, then what it would do is it would actually say that singing, sang, song, all of these relate to the word sing. SING. And these are not any different words. So that I mean all the relevant documents with the word sing, even if and some document contains SUNG, then it would actually determine that this particular word actually relates to SING. So it would actually retrieve those documents. So basically, Stemmer and Morphological Analyzer is quite prominent and quite useful for applications like information retrieval. Right? Parts of speech tagger. Right. So there are at least, let's say, in case of English, there are eight parts of speech. Right? For example, noun, verb, adjective, and so on and so forth. So parts of speech tagger, this application automatically assigns the parts of speech to any particular word in any running text. All right. So meaning to say that okay, we have one text, running text, and then if we provide this text as input to the tagger, then it would actually tag whether that this particular word is a noun or a verb or all. So where do this application come into play? Where is it useful, for example? In Nepali, I mean it's not very prominent, but in languages like English, for example, I might not be able to pronounce in the same way as it should be because I'm not a native speaker of English, right? However, the word book itself, right? I want to buy a book versus book me a flight. These are pronounced differently because the way these two words, the same word, appears in different texts are in a different context. In the sentence like I want to buy a book, here book is a noun, right? Whereas book me a flight ticket, here book is a verb. So that's just an example. So for example, in the text-to-speech application, depending upon whether it's a verb or a noun, the system has to pronounce it differently. Because there are different pronunciations even for the same word, right? So it's very useful in applications like the text-to-speech, parts of speech tagger. Similarly, later on I'll also talk about another application. Similarly, there is this named entity tagger, named entity recognition system itself, right? Which basically, it's very useful in information extraction. For example, you have a big corpus of text and you want to extract all the proper names. All the proper names, meaning to say that organizations, it could be persons, it could be other named entities, right? Without a post tagger or a parts of speech tagger in place, you cannot really do that all. Because if you have a parts of speech tagger, then it would actually tag such entities as proper names, proper nouns. And you could just, a named entity tagger could just actually extract all the proper nouns from the text. All right? So parts of speech tagger is very useful in named entity recognition and text-to-speech. Next. Grammar checker, yes. So checks the text in the sentence level and determines whether it's grammatically correct or not. Right? However, there are different formalisms even for grammar checking, right? Even for grammar checking. So if languages like English follows some context-free grammars, for example, in Nepali, it's a relatively different language in the sense of how the way the sentence are structured. So our language is considered as a free word order language, meaning to say that although we have a fixed written structure, right? That's subject, object, and verb. For example, mo bhat khanchu. In case of English, it's I eat rice. That's subject, verb, and object, right? So there is a SVO relationship. We have a SOV relationship, and then the way our language has its roots from Parnadi, right? That's basically for develop some Sanskrit scholar who actually developed a grammar for Sanskrit. Right? So it's more or less there. So it also has to follow this Parnadi dependency grammar. That's the different type of grammar that's related to our related languages in Nepal. That's about the grammar checker. I already talked about the named entity recognition system. Automatically detects proper names of people, organizations, or other defined objects, often referred to as named entities. Then another very burning topic of the day of these days is sentiment analysis or opinion mining, right? Sentiment analysis or opinion mining. For example, you want to buy a mobile phone, and these days, gone are the days when you actually tour from shop to shop, or let's say, right? What you do these days is basically are interested in the reviews, right? What people have, what people think about the particular product, what are their views and all these things, right? So from that perspective, sentiment analysis or opinion mining is a very important topic today, and deals with classifying the opinions into documents in positive, negative, or neutral. That's basically one part of it. And it also determines the degree of opinions, how positive, how negative. Sentiment analysis is a very interesting and a challenging problem. Fortunately, that also happens to be my PhD topic, my PhD research topic. And there's some interesting pattern here, right? For example, if we were to just take a lexicon of positive and negative list, right? You might think, okay, well, I can have a positive list and negative list, and based on that I can analyze the sentiments, but you may actually fall short on that. Because good is a positive word in itself, but too good is a negative word, right? So even some negations like not, or other constructs like too, for example, TOO, too good, can actually flip the polarity of the opinion to the other side. All right? And then also the degree of opinion, so how positive, to what degree? Is there very high scale positive, or just a middle one, or just a very low, right? For example, we have these ratings, right? 5-star rating, or 4-star rating, and 3-star rating, and all those things. So that's about sentiment analysis. Next slide. Text categorization and classification, right? So this is also a very, very interesting and a very interesting problem in NLP, right? So given a large amount of text, for example, you would want to categorize this into different categories, right? For example, we have these online portals which actually already do themselves, right? For example, it could be sports. A particular news, a particular article could be related to for sports, some may be about politics, some may be about society, and so on and so forth. What if we want to give a NLP system to actually categorize them into different categories? So that's basically that deals with the text categorization. And then there is another problem called text classification, which basically classifies the text into two different classes. For example, there is this, I think it's a well-established problem which you might have already heard about. Now it should not be no longer a problem. For example, this classifying emails as spam or ham. Right? There could be several emails which you are irritated. Right? There could be several promotional emails, not necessarily, which has got nothing to do with your, let's say, personal contacts or all these things. So I think it's already in place. To some extent, it's a solved problem that the emails could are these days automatically categorized or classified as spam or ham. Right? Whichever the system thinks that this is not ham, this is spam, then it will actually redirect in the junk folder or maybe even delete it. So that's a text categorization and classification. Machine translation system, which I already talked in the beginning of the slides. That's also quite important. We have, for example, Google Translate these days, which has support for 100+ languages, right? So that's also a useful application. And that's machine translation. OCR system, right? For example, we have image documents, right? Image documents. Necessarily, the documents are actually preserved in this format, necessarily in archive houses, right? And let's say publication houses as well. And then what happens later on? Let's say you just have the documents in PDF or JPG and whatsoever, right? But then you cannot really do all the full-fledged text processing utilities or tasks in the image format. So you need to convert that into text format. So for that purpose, OCR application, optical character recognition system, is very useful. Converts text into image document formats, into editable text. Then we have handwriting recognition system as well. You might provide input to your PDAs or other devices, electronic devices, with the stylus or other input tools or devices, and that needs to be recognized by the system, right? And then converted into digital text. If that's the case, then that's known as online handwriting recognition system. However, if you just scan your handwriting text and then provide input to the system and it converts into digital text, then that's offline handwriting recognition system. Okay. Next. Text-to-speech system, TTS system, it has the capability to read aloud texts, right? Read aloud text. Whatever input text is given. Just imagine how useful it's going to be the, let's say, visually impaired community or non-literate people, right? Even those of we are not, let's say we are able. For example, we are driving a car and you just want to hear out the SMS text and all those things, then that can be done by the text-to-speech system. Speech recognition system, it's recognized the speech, right? So, if it is a speech transcription system, then the text as input as speech, and then the output would be in the form of a transcribed text, right? If it is, let's say, speech-to-speech translation, in that case, we have input as speech and output also as speech. All right. So these are some of the NLP applications that I actually wanted to give you a brief overview. So let's move to the next slide. So with this, now we can see that NLP has a big role in empowering the society, right? So because necessarily every day we actually encounter human to machine communication. The machine has to communicate to the humans, and we humans have to communicate to the machine. All right. So there are a lot of useful systems which can actually empower the society or help us transform the society. For example, machine translation system, right? So I might not know the particular language, but a machine translation system will aid me to actually get the gist of what is being intended in that particular language, right? Similarly, we have this OCR and TTS, right? OCR and TTS. For example, just imagine some book reader to the visually impaired guy, right? So what the system does, it actually OCRs some let's say book in PDF, and then the converted text is passed in the pipeline fashion to the text-to-speech system, right? And that will actually read aloud the contents of the text. Similarly, lately I am working with the Nepali text-to-speech system, and then the client is one of our clients is the visually impaired community. I just get amazed at the way how they work, right? Every time I meet, they say, well, I had 4 or 5 Skype meetings today. These guys, they write proposals themselves, right? And then what happens in how they work with? Sometimes I wonder, and sometimes I think that they are more smart. They are smarter than we able people, right? So. And how do they use the software or the technologies? It's through the help of screen reading software, right? So they use this different software, like there is this open source variant as well, NVD, right? And then there are other proprietary systems as well. So with the help of these systems, you just imagine if there was not these systems in place, then how would they be such? How would they perform in the same manner as they are doing right now, right? So, speech recognition system and AI have already reached promising milestones, and the latest achievement of the robot Sophia, for example. Sophia, it had gone very viral in the past 2-3 months, and it has the capabilities of not really just understanding the input or the speech or whatever of the humans, but it also has the capability to show emotions. That's a very big achievement or milestone in the field of AI, natural language processing, and machine learning as well. Okay? Okay, I think I have gone to the very end. Let's see if we have for those slides. Yeah. So our cars are getting driverless, right? Our cars are getting driverless, and our homes are even getting smarter. So in all of these, NLP comes into play, natural language processing, because this necessarily deals with human-machine interaction or communication. Right? And what I would like to end this slide presentation with this final statement: NLP will have a strong say in the human-machine communication technologies in the future. Thank you.